In this video, we're going to focus on solving trigonometric equations. So let's start with the one that we have on the board. 2 sine x plus cosecant x equals 0. What do we need to do first? So cosecant x is the same as 1 over sine x. It's a reciprocal function. And right now we can't really solve for sine x. What we need to do is multiply both sides by sine. 2 sine x times sine is 2 sine squared x. 1 over sine times sine, the sines cancel, so we just get 1. And 0 times sine is 0. So this is what we now have. So if we subtract both sides by 1, 2 sine squared is equal to negative 1. And if we divide by 2, sine squared equal negative half. Now sine squared cannot, whenever you square something, it can't equal a negative number. So therefore there's no solution for this one. So that's it for that problem. Let's try our next example. Cosine x minus sine x is equal to 0. So what do you think we should do for this one? Let's add sine x to both sides. If we do so, cosine is going to equal sine x. And then after that, let's divide both sides by cosine x. So cosine over cosine, that cancels to 1, and sine over cosine is tangent. So therefore, tangent x is equal to 1. So tangent of what angle is equal to 1? To figure that out, you can type it in your calculator. Type in inverse tangent of 1. Hopefully, you can also, if you know the unit circle, you can use that to figure this out. The other thing you could do is know your triangles. There's 2 triangles you need to know. The 30, 60, 90 triangle and the 45, 45, 90 triangle. Across the 30 is 1, across the 60 is root 3, across the 90 is 2. So it can't be the 30, 60, 90 triangle. The reason being is, using SOHCAHTOA, tangent is opposite over adjacent. And if we divide opposite over adjacent, we won't get 1 if we use the 30, 60, 90 triangle. If you do 1 over 2, root 3 over 1, because all sides are different, there's no way it's going to cancel to 1. But the 45, 45, 90 triangle, 2 sides are the same. And the square root of 2 over the square root of 2 can give you 1. So therefore, we know that the reference angle is 45. If you type in inverse tangent of 1 in your calculator, make sure it's in degree mode, you're going to get 45 degrees. Now, once you figure out the reference angle, using the calculator or those common triangles or the unit circle, here's what you need to do. Alright, so we had tangent x is equal to 1. And one of the answers is 45. Because tangent is positive, you need to know that our answer lies in quadrant 1 and 3. We already have the answer for quadrant 1, that's 45. But we also need the answer in quadrant 3. So to figure this out, we need to find the angle from here to here. This is 180 plus 45. So 180 plus 45, the other answer is 225. Now that's the answer in the range of 0 to 360. If it's from 0 to 2 pi, if you get a question like that, typically they want the answer in radians. So if we convert degrees to radians, multiply it by pi over 180. If you divide it backwards, 180 divided by 45 is 4. So this becomes pi over 4. And 225 is 5 times the value of 45. So 225 is 5 pi over 4. So those are our answers in radians. Now sometimes you may have to find an equation that describes all of the solutions. Typically, in a problem like that, you won't see this restriction. Now what you could do is say you can add 2 pi n to each of your answers. If you do that, you can't get it wrong. That's one way you can write it. However, some teachers may want you to write a single equation that could describe both of those numbers. And for this one, we can. Notice that pi over 4 and 5 pi over 4, they differ by pi, or 4 pi over 4. Because of that, we can write a single equation. We can say pi over 4 plus pi n. If you plug in 1 for n, you're going to get 5 pi over 4. So we can, instead of writing these two separate equations, we can write one equation that will describe all the answers where tangent x is equal to 1. So that's it for that equation. Let's try our next problem. So let's say if we have 3 tan cube, let's say it's equal to tan x. How would you solve that problem? Now, what you don't want to do, you don't want to divide by tangent x. Instead, you want to subtract tan x from both sides. So 3 tan x minus tan x. 3 tangent cube x. If you divide both sides by tangent, you're going to lose an answer. Instead, what you want to do is factor out tangent x. 3 tan cubed divided by tan is 3 tan squared. And negative tangent x divided by tan is negative 1. Alright, so this is what we have. After you factor it, separate it into two equations. Tan x is equal to 0, and 3 tan squared x minus 1 is equal to 0. So at what angles is tangent 0? Tangent is 0 at 0 and pi. If you type tangent of pi, you get 0. If you type in tangent of 0, you get 0. For the other one, we need to add 1 to both sides, and then divide by 3. So tan squared is 1/3. So if we take the square root of both sides, the square root of 1 is 1, and so we have 1 over root 3. If we rationalize it, if we multiply top and bottom by radical 3, tangent x, therefore, is equal to plus or minus root 3 over 3. Now for this answer, you can't use a 30, 60, 90 triangle or 45, 45, 90 triangle to get this answer, because it's not in any quadrant, it's on the x-axis. So either you know it based on a unit circle, or you can use a calculator to get one of the answers. For this one, we can use one of the triangles to figure it out. So which triangle has root 3? It has to be the 30, 60, 90 triangle. Let me just write these answers that we have. Now let's find the other answer. Across the 30 is 1, across the 60 is root 3, across the hypotenuse is 2. So how can we figure this one? Now keep in mind though, before we rationalized it, our answer was 1 over root 3. It's easier to find out the angle in this form. Tangent is opposite of adjacent. So which angle is opposite to 1 but adjacent to root 3? 30 is opposite to 1 but adjacent to root 3. So therefore this is 30 degrees. At least that's the reference angle. Once you have the reference angle, you can find the other angles. Because it's plus and minus, we need the answer in all 4 quadrants. In quadrant 1, the angle is 30. But in quadrant 2, the reference angle is 30, but it's going to be 180 minus 30. 180 is over here. So we're going to get 150. In quadrant 3, it's going to be 180 plus 30, which is 210. And in quadrant 4, 360 minus 30, which you'll get 330. These are the 4 answers. And if we want to convert them into radians, let's see, 30 degrees times pi over 180. Cancel the zeros. Divide it backwards. 18 divided by 3 is 6, so this is pi over 6. This is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So those are all the answers. But now, how can we rewrite? How can we, write a general equation for the answers? So we have all the answers in the range of 0 to 2 pi. But let's say if we want to find all solutions, if there's no restriction, how can we do that? So here's our restricted domain. If there's no domain in this problem, what you could do is say pi over 6 plus 2 pi n, 5 pi over 6 plus 2 pi n, and just add 2 pi n to each answer. That's one way to do it. However, instead of writing 6 equations, we can reduce it to maybe 2 or 3 equations. To describe these solutions, we can write one equation, just pi n. Because when n is 0, we get 0. When n is 1, we get pi. That's all we need for those two answers. Notice that pi over 6 and 7 pi over 6 differ by pi. So for those two, we can say pi over 6 plus pi n. When n is 0, we get pi over 6. When n is 1, we get 7 pi over 6. And these two, they differ by pi. So the other answer is 5 pi over 6 plus pi n. If n is 1, you get 11 pi over 6. So that's it for that particular problem. And then for our final example, let's try this one. 2 sine squared x plus 3 sine x plus 1 is equal to 0. Now you need to recognize that this looked like a quadratic equation. Let's let's factor by substitution. Let's say a is sine x. This would be 2a squared plus 3a plus 1. And we're going to factor it by trial and error. So what times what will give us a squared? It has to be 2a and a. Now we need two numbers that multiply to positive 1. It could be 1 and 1 or negative 1 and negative 1. But because this is plus 3, we're going to use 1 and 1. And notice that it's factored. 2a, let's test it out, times a is 2a squared. 2a times 1 is 2a. 1 times a is 1a. And then finally, 1 times 1 is 1. 2a plus 1a adds up to 3a. So that's the factored form. Now we're going to replace a with sine x. So what we have is 2 sine x plus 1 times sine x plus 1 is equal to 0. And then we're going to separate each one and set it equal to 0. So on the right, sine x is equal to negative 1. Based on a unit circle, sine of 3 pi over 2 is negative 1. So x is 3 pi over 2, which is the same as 270 degrees. Here, if we move the 1 to the other side, we're going to get negative 1 and then divide it by 2. So sine is negative in quadrants 3 and 4. Now, if you type this in your calculator, inverse sine of just positive a half, this will give you the reference angle of 30. Now, if you want to find the angle in quadrant 3, it's 180 plus the reference angle. So x is 210. In quadrant 4, it's 360 minus the reference angle, so it's 330. And then let's convert each into radians. So 210 times pi over 180. Cancel the zeros, so we have 21 over 18. If we divide by 3, 21 divided by 3 is 7. And 18 divided by 3 is 6. And 330, if we convert that to radians, is going to be 11 pi over 6. So these are our answers. Now, none of these answers differ by pi. So for each one, just add 2 pi n if you want to find all of the answers if we don't have a restricted domain. So that's it for this video, and thanks for watching.